Sometimes, late at night, when the house is quiet and the screens are finally dark, I like to imagine that the universe is listening with me, not to music, not to words, but to echoes, very old echoes. I sit there in the dim light, maybe with a cup of something warm between my hands, and I think about all the explosions that are happening right now out there, far beyond anything we can see with our eyes. Not just the ones we know, not just the famous supernovas we hear about in documentaries, but stranger, deeper bursts. The kind that don't even look like explosions in the way our minds expect. The kind that warp space, bend time, twist light, stretch reality, and then in some quiet way, touch us. I close my eyes and I try to feel them like distant thunder on the other side of the sky. It's funny because when we hear the word explosion, we usually think of something quick and loud and bright, like fireworks, or a car backfiring down the street, or a balloon popping right next to our ear. We think of heat and shock and chaos, but the universe doesn't really care about our sense of drama. Out there, some explosions are so slow they look still. Some are so invisible they might as well be ghosts. Some don't explode outward with light, but with gravity, or with ripples in space itself. And some are so powerful that if we could see them with naked eyes, even from halfway across the universe, they'd outshine entire galaxies. For a moment. For the blink of a cosmic eye. I remember lying on the hood of a car once, years ago, in a small, quiet place with almost no streetlights. The metal was still warm from the day. The air smelled like dust and a little bit of dry grass. There was this thin, sharp chill sliding in under my jacket. Above me, the sky felt huge, but also oddly flat, like someone had painted small white dots onto a dark ceiling. I knew, logically, that each of those dots was a star, that some of them had already exploded long ago. I knew this in the way we know facts, the way we repeat things we've been told. But it didn't feel real yet. Then, sometime around midnight, a bright streak tore across the sky, a meteor. Just a grain of rock, probably no bigger than my hand, burning up in our atmosphere. It left this fading trail that seemed to hang there like a thought I couldn't quite finish. And my first instinct was, oh, that's an explosion, I can understand. I could almost hear it like a soft hiss in my head. I could almost smell the burnt air, even though I knew that was just my imagination. But I also knew that out there, much farther away, there were things burning and breaking on scales that dwarfed that tiny streak. Things exploding with so much energy that our little meteor would be like the faintest dust spark in comparison. And we might never see them with our eyes, only with instruments, only with math, only with patience. That thought stayed with me. It still does. There are, for example, these strange flashes called gamma ray bursts. If supernovas are like the bright fireworks of the universe, then gamma ray bursts are like a single, sharp rifle crack that echoes across a whole continent. They are brief, frighteningly bright flashes of the most energetic light you can imagine. Not the soft glow of a candle, not the warm yellow of a lamp, but a kind of invisible, violent brightness that can cut through almost anything. We think some of them happen when very massive stars collapse into black holes. And in those last moments, instead of just spreading their guts out in all directions, they shoot out two narrow jets of energy like twin lances blasting through the star's own body and into space. The burst can last for seconds, sometimes minutes, just a heartbeat. But in that heartbeat, they can release more energy than our sun will put out in its entire lifetime. I like to picture one of those jets sweeping past an empty corner of space. No planets, no eyes, no one to see. Just dust swirling in slow motion, thin gas clouds stretched like veils, and then this sudden brutal wave of energy rushing through. If you could stand there, if somehow you could float in that vacuum and not be torn apart, you wouldn't hear anything. Space doesn't carry sound. But maybe you'd feel something in your bones, like a pressure that has no direction. Maybe you'd see atoms themselves pushed, stripped, forced to glow in colors you don't even have names for. Of course, we never see all that directly. We only see the small bit that happens to be pointed toward us, the narrow beam that crosses our path. To us, it's just a rising spike on a detector somewhere, a sudden alarm on a screen, a silent flare in a graph. And yet, knowing what it means, what it stands for, makes me feel small, yes, but also strangely connected. Like I'm catching the tail end of a scream from a star that died long before humans even learned how to walk on two legs. And gamma ray bursts are just one kind of explosion beyond supernovas. There are quieter, weirder ones. Take magnetars. I always loved that word. It sounds like a character from a strange old story, a wanderer with a hidden past. But magnetars are real. They are a kind of neutron star, which is already a wild thing to imagine. Picture a star much bigger than our sun that explodes as a supernova, and the core that remains is crushed down so tightly that atoms collapse. Protons and electrons merge into neutrons. You get this city-sized sphere of pure, dense matter. A teaspoon of it would weigh as much as a mountain. That alone is enough to make my skin feel tight, like the air around me just got heavier. Now add an absurd magnetic field to that. A magnetic field strong it could erase your credit cards from halfway to the moon. So strong it can twist and crack the crust of the star itself. That's a magnetar. Sometimes those magnetic fields rearrange themselves, like a twisted rubber band snapping back into place. When that happens, the magnetar can release a sudden burst of energy, a flare. In a fraction of a second, it can put out more energy than the sun does in tens of thousands of years. But it doesn't look like a big blooming fireball. It's more like a violent, invisible shudder. A spike of high-energy light that flashes and fades. To human eyes from far away, the sky doesn't even flicker. And yet, somewhere, a skies of a city just screamed. I remember once as a kid watching a metal bridge tremble a little as a heavy truck rolled over it. The sound was low and dull, more felt than heard. The railings buzzed under my fingers. That's how I like to imagine a magnetar flare. The universe itself shivering for a moment, then settling down as if nothing happened. No big show. Just tension released. The more I learn about these things, the more I feel like supernovas, as dramatic as they are just one part of a much larger language of cosmic violence. There are events out there that don't even look like explosions to us, because we're so used to thinking in terms of light and heat and expanding clouds. But what if the explosion isn't in light? What if it's in gravity? Black holes give us that. When two black holes orbit each other, slowly spiraling inward, they lose energy by sending ripples through the fabric of space itself. We call those ripples gravitational waves. They stretch and squeeze space as they move, like the surface of a pond trembling after you drop a stone. Except the pause everything. These waves are usually tiny, so small that by the time they reach us, they make distances change by far less than the width of an atom. But when two black holes finally collide and merge, the ripples are strong enough that we can measure them. That collision is a kind of explosion. Not of light, not of sound, but of gravity, a sudden rearrangement of mass and energy that sends a sharp pulse through space-time. I like to think about the moment just before they collide. Two dark, invisible spheres dancing faster and faster around each other, space itself swirling around them, time slowing down near their edges. If you could somehow hover nearby and survive, you wouldn't see much. Black holes don't shine. But you might feel something strange, like the universe around you leaning and swaying in ways your body was never built to sense. Then, in a final rush, they fall inward together, merge into one, and the churning settles into a quieter, calmer spin. Far away, there is no flash, no glow, no expanding cloud, just a delicate wobble passing through the cosmos, eventually brushing past Earth. It is so soft and so small that it takes vast, patient machines, long tunnels with lasers bouncing inside them, to notice the brief stretch and squeeze of space, a tiny twitch, an echo of an invisible explosion. When those first waves were detected, years ago, I remember reading about it and feeling this odd mix of awe and loneliness. Awe, because we had just heard two black holes collide more than 1 billion light years away. Loneliness, because the event itself had come and gone long before there were humans or Earth or even the sun. We were late to the story, as always. We were catching the whisper of something that had already turned to silence. It's like walking into an empty room and still smelling the faint trace of someone's perfume. They're gone, but a part of their presence is still hanging in the air, thin and almost unreal. The universe is full of those traces. Some of the most powerful explosions in the cosmos probably happened long before there were even galaxies as we know them. In the early universe, when everything was hotter and denser and stranger, matter and light wrestled in ways we can barely imagine. There might have been exotic events back then, phase transitions, cosmic strings snapping, huge bursts of energy as the universe cooled and changed its own rules. We don't see those events directly, they are too far away in time. But maybe some of the patterns we see now, some of the large-scale structures, some of the faint backgrounds of radiation, are the distant, stretched-out remains of those ancient bursts. When I think about that, my mind goes quiet. Just this sense of a young universe throwing tantrums, erupting and settling, trying to find some kind of balance. And now, billions of years later, we're here. Tiny creatures with soft bodies and fragile memories trying to reconstruct what happened by studying the faintest clues. We're like detectives entering a house after a great storm, looking at the broken windows, the cracks in the walls, the pattern of fallen leaves in the yard, and trying to guess how strong the wind was, which way it blew, how long it lasted. There are other kinds of cosmic explosions that are more gentle, at least from our distance. When stars like our sun reach the ends of their lives, they don't always explode in a single violent blast. Sometimes they swell up into red giants, their surfaces cooling and stretching until they swallow nearby planets. Then they puff out their outer layers in slow, steady waves. These waves drift away, glowing softly, creating what we call planetary nebulae. The name is misleading. They have nothing to do with planets. They're just shells of gas lit from within by the hot, small core that remains, a white dwarf. These are not sudden explosions. They're more like long exhalations. I imagine floating near one of those nebulae. Thin, colorful gas clouds glowing in greens and reds and blues, like the soft smoke of incense curling in slow motion. If I could breathe there, maybe it would smell faintly metallic, like cold iron dust and some strange chemical tang. The leftover star in the center would be small but blazing hot, like a single burning coal at the heart of a fog. This, too, is an ending, a quieter one. No shockwave tearing through galaxies, no jets punching holes in space, just a star gently letting go of its outer self. And yet, even that is a kind of explosion in a way. A release of material that once was locked deep inside a nuclear furnace. Carbon, oxygen, nitrogen, the same atoms that will someday become parts of planets, oceans, trees, and breathing lungs. When those layers drift out and mix with the wider galaxy, they enrich it. They plant the seeds for future worlds. It's strange to think that our own bodies carry the ashes of ancient explosions. The iron in our blood, the calcium in our bones, the oxygen we pull into our chest with every breath. They all came from stars that tore themselves apart or peeled themselves open in one way or another. We walk around every day making coffee, checking messages, tying our shoes, and we don't feel like we're made of anything dramatic. We feel ordinary, clumsy, tired. But inside us there are atoms that were once locked in the hearts of stars that died in unimaginable violence. Sometimes I touch my wrist and feel my pulse, that gentle thumping under the skin, and I think, this is a slow echo of cosmic explosions. My heartbeat is powered by energy that came from sunlight, and that sunlight came from nuclear reactions in our sun, and those reactions are sustained by the elements left behind by even older stars. It's a chain that goes back and back into darkness and fire. There's another kind of stellar explosion I think about a lot, something called a kilonova. The name sounds small, like kilo should mean less than super, but in reality, kilonovas are terrifyingly intense. They happen when two neutron stars, those ultra-dense leftovers from supernovas, spiral together and collide. Neutron stars are already extreme, but when two of them merge, the violence of that event is almost beyond words. In the last moments, they orbit each other so fast that each circle might take less than a millisecond. Tidal forces tear at them, stretching them like dough, flinging out chunks of neutron-rich matter. When they finally smash together, they create a burst of gamma rays, a blast of gravitational waves, and then, in the material that sprays out, some of the heaviest elements in the universe are forged. Gold, platinum, uranium, heavy, rare, precious atoms are born in those moments. I sometimes picture one of those collisions, not as a scientist, but like a dream. Two dark, tiny stars, each maybe 20 kilometers across, whirling closer and closer. Around them, thin wisps of gas and dust glow faintly from the radiation. There's no air, no wind, but you can imagine a kind of silent howl as space curves and twists. Then contact. A flash not like a fireball with flames, but like the sudden, white-hot tearing of reality. Matter flung outward, glowing with a weird, deep, bluish light that fades to red as it cools. If you could stand very far away and watch through some impossible, perfect telescope, the kilonova would look like a star that suddenly brightens and then fades over days, changing color as it does. A short, intense bloom of light in the blackness. And somewhere in that bloom, atoms of gold are forming. Some of those atoms in some galaxies will end up locked in rocks, then melted into molten cores, then maybe lifted into the crust, then maybe one day dug up by hands, polished, shaped into rings. A person might slide one of those rings onto another person's finger and call it a promise, a symbol of love, of commitment, of something lasting. And they won't know that the metal they're touching was born in the death dance of two neutron stars, in a kilonova explosion that shook space-time itself. I think about that when I see jewelry in a shop window. All that soft light reflecting off gold bands and chains. There's a hush in those displays, a kind of quiet luxury. But beneath that, there's a history of fire and collision and cosmic violence. It's almost funny in a tender way. We take the wreckage of dead stars and turn it into something we give each other as gifts. There are even stranger explosions, the ones that might not be from stars at all. Imagine a black hole that isn't the corpse of a massive star, but something that formed in the very early universe, when everything was so dense that even small regions could collapse under their own gravity. These are called primordial black holes. We don't know if they exist, not for sure. But if they do, the smallest of them, tiny ones with much less mass than a star, would slowly evaporate over time. Yes, evaporate. Black holes, it turns out, are not completely black. Quantum effects near their edges, their event horizons, let them leak a faint, slow trickle of particles. Over unimaginable stretches of time, this leak makes them lose mass. For big black holes like the ones made from stars, this process is so slow it's basically irrelevant. But for very small black holes, it matters. They would lose mass faster and faster, shrinking, their temperatures rising, until finally, near the end, they explode in a burst of high-energy radiation. A black hole dying in a final flash. We've never seen such an explosion. If primordial black holes are out there, and if some of them are small enough, some might be popping right now in distant corners of the universe, like microscopic fireworks in the deep night. The idea that space might be sprinkled with tiny, vanishing bursts from evaporating black holes feels both eerie and beautiful to me. It makes me think of fireflies. When I was younger, I spent a few nights in a place where fireflies were everywhere. The air was warm and thick with this slightly sweet, earthy smell, and the grass brushed against my ankles as I walked in the dark. All around me, tiny lights blinked on and off. Not in unison, not in a pattern I could follow, but with this random rhythm that somehow felt alive. A light would appear, hang there for a breath, then vanish. Another would flicker in the corner of my eye, then fade. I loved the way the darkness seemed full of hidden, brief events, little lives flashing their messages into the night and then going quiet. Primordial black holes, if they exist and if they die this way, would be like cosmic fireflies, blinking once in a burst of radiation, then leaving nothing behind. No remnant, no ashes, just a momentary mark on the universe, and then silence. We may never know if they're real, but the possibility alone makes the dark feel less empty. There are even explosions we can't see because they happen in the emptiest places. Imagine a region between galaxies, far away from stars and dust, just thin, ghostly gas scattered over light years. In those places, when a supermassive black hole at the center of a distant galaxy feeds on matter, it can shoot out jets of particles and energy that travel for millions of light years. These jets can slam into that thin gas, heating it, pushing it, carving out giant bubbles in the space between galaxies. From our point of view, if we map that gas with radio waves or X-rays, we see vast cavities, empty regions where something powerful has swept through. They're like scars in the cosmic web. I imagine drifting there, in that intergalactic space. No stars close by, just a soft, almost non-existent fog of particles. Then passing through, a wave of energized matter, thin but fierce, like the front of a hot wind. It wouldn't feel like wind, not in the way we know it. But you might sense the temperature jump, the sudden agitation of particles, the invisible pressure. Then, long after the jet has passed, you'd be left in a bigger, hotter bubble of space, a giant explosion stretched out over millions of years. That's the thing that keeps circling in my mind. Not all explosions are quick. On human timescales, we think of them as instant. A bang, a flash, done. But the universe works on scales where an explosion can last 1,000,000 years or 100 million. There are clusters of galaxies where the central black hole has been blowing bubbles in the hot gas for eons, turning the heart of the cluster into a layered structure of cavities and shocks. It's like watching a slow-motion volcano underwater, forever burping out plumes that rise and spread. If you speed it up in your mind, you see waves pulsing outward, shells of compressed gas moving like ripples in jelly. They are so gentle at any moment that no single instant looks dramatic. But over time, they reshape entire regions of space. We live in the afterglow of many such events. Our own galaxy bears the marks of ancient explosions. There are giant lobes of gas and radiation extending above and below the Milky Way's center, like huge, invisible balloons. We call them the Fermi bubbles. They probably came from a burst of activity in our central black hole millions of years ago, or maybe from intense star formation and supernovae. Either way, something happened there that pushed material outward on a vast scale. I like to imagine the sky of Earth back then, if there had been eyes to see it in the right wavelengths. Maybe the center of the galaxy would have glowed differently, with a soft, hazy brightness, a faint, bruise-colored light stretching above and below. Life on Earth, if it existed in simple forms in the oceans, would never have known. Little microbes drifting in warm water, unaware that far above them the galaxy's heart was flaring. That contrast moves me. The idea that the universe can roar at one scale and whisper at another at the same time. In a way, our own lives have explosions too, just on a different kind of stage. Sudden breaks, sudden changes, moments where everything we thought was stable is torn apart, and we're left in a cloud of debris, trying to find our shape again. The end of a relationship, the loss of someone we love, A move to a new place where nothing smells right, nothing sounds familiar. Those are emotional supernovas. They hurt. They scatter pieces of us. But just like with real supernovas, something new can form from that. Heavy elements are made in the violence. New stars are born in the gas clouds left behind. I think about that when I remember my own personal explosions. Times when it felt like my inner world had cracked open. The way my chest felt tight, like gravity had suddenly increased. The way sounds seemed too sharp or too distant, like I was underwater. In those moments, it's hard to imagine that anything good could come from the destruction. And yet, looking back, I can see how those events cleared space for new patterns, new connections, new versions of me. Not in a neat, tidy way. Not in a comforting, everything happens for a reason kind of way. Just in the simple, physical sense that when something breaks, its pieces can sometimes reassemble into something different. The universe doesn't promise us happy endings. It just shows us that endings and beginnings are often the same event seen from two directions. Cosmic explosions beyond supernovas remind me of that over and over again. A gamma ray burst can sterilize whole regions of space, stripping planets of atmospheres, killing possibilities. A kilonova can also create the gold that will one day be part of a wedding ring. A magnetar flare can release energy that might in some far future be harnessed by some distant civilization as a power source. Black hole mergers send out gravitational waves that we detect as data, and that data turns into insight, and that insight changes us, even if just a little. We are so small inside all of this. When I walk outside at night and look up, the sky over a city is usually washed out, pale from streetlights. Only a few stubborn stars punch through the glow. The air smells like car exhaust and damp pavement. There's a faint hum of traffic, a distant siren, a neighbor's TV muffled through walls. It doesn't feel like a stage for grand cosmic drama. It feels domestic, ordinary. But if I let my mind stretch, I can layer another picture on top of that. Beyond the haze, beyond the clouds, are galaxies spinning, clusters colliding, jets firing, black holes merging, neutron stars crashing, magnetars flaring, primordial black holes maybe popping like invisible popcorn. The universe is not calm. It only looks calm from here because we are so far away from most of the noise. We live in a quiet corner on the thin skin of a small planet, sheltered by distance and scale. And yet we are connected to all of it. Our telescopes and detectors are like extended senses, long, fragile fingers reaching into the dark. They catch the faintest vibrations, the softest flashes, and bring them back to us as numbers. We turn those numbers into colors, into sounds, into images. Sometimes scientists even take the data from gravitational waves and turn it into audio, compressing the frequencies so we can hear the rising chirp of two black holes merging. I listened to one of those once through headphones, alone in my room. It was such a simple sound, so short and unassuming. A little whoop, like someone sliding a finger up a piano key. If you didn't know what it was, you could mistake it for a glitch, a tiny electronic hiccup. But I knew. I knew that sound was a translation of an event that had released more energy in a fraction of a second than all the stars in the observable universe emit in the same time. But instead of light, it was energy in gravitational waves. And my brain had turned that into a soft upward chirp. I remember taking off the headphones and just sitting there, feeling the weight of that. Not in a heavy way, just aware. Like I had just eavesdropped on a conversation between black holes. We are, in a way, the universe listening to itself. The atoms that once were parts of stars have cooled and collected into us, and now we point instruments back at the sky and ask, what happened? What is happening? What will happen? Cosmic explosions beyond supernovas are some of the loudest answers we've found so far. They tell us that the universe is not a static painting, but a restless, evolving thing. That even in the darkest regions there are sudden, fierce changes. That creation and destruction are not opposites here, but partners in a long, slow dance. Sometimes, when everything feels too much, when the news is all noise and the future seems thin and sharp, I like to shrink my focus down and imagine just one event, one gamma ray burst in some far off galaxy, one magnetar flare, one black hole merger. I picture it in as much detail as I can, the light, the motion, the silence, the strange geometry of it. I let myself feel the scale, the distance, the fact that this thing is happening regardless of whether I'm worried about my own life. And oddly, that doesn't make me feel insignificant in a bad way. It makes me feel held in a very strange sense. Like I am part of a story so large that my own fears and hopes are both tiny and precious. Tiny because they are just one thread in a huge tapestry. Precious because they are one of the few places in this vast, explosive universe where matter has arranged itself into a being that can feel anything at all. Explosions out there don't feel. They just happen. They don't regret, they don't hope, they don't grieve. They just release energy and move on. We do all of that. We are made from the leftovers of stars and black holes and neutron stars, and we carry inside us something that wasn't there before: awareness. The ability to look up at the night sky, to feel the cool air on our face, to hear the distant rumble of a city, or the soft chirp of a cricket, and to wonder what lies beyond. To imagine explosions we will never see, to calculate their energies, to assign them names, to draw diagrams of their light curves, and beyond all of that, to feel moved by them, to feel awe or sadness or fear or comfort. Maybe that is our role here, if we need a role at all, to be the soft, fragile places where the universe becomes aware of its own storms. So, tonight, if you find yourself awake when the world around you is sleeping, maybe step outside for a moment, or just look out a window. Let the night air slip into your lungs. Notice any smells: the dampness of recent rain, the dry dust of a hot day, the faint smoke from someone's chimney, the metallic tang of a city. Listen to the small sounds, the distant cars, the rustle of leaves, the buzz of a street lamp. Feel the ground under your feet, solid and patient. Then, if you like, let your mind drift upward, past the clouds, past the thin blue shell of our atmosphere, into the dark. Picture the quiet points of light, the scattered stars, the hazy band of our galaxy, and somewhere, far beyond what you can see, imagine a star collapsing, a magnetar flaring, two neutron stars embracing in one final, violent hug. A black hole swallowing another black hole, in a silent crash that sends ripples through everything. All of that is happening whether we watch or not. All of that is part of the same universe that gave you your heartbeat, your breath, your memories. We are not at the center of it all. We are not the purpose of it all. But we are here for this brief moment, able to witness a tiny slice of its endless fireworks. To listen to echoes that have traveled for billions of years to reach us. To turn those echoes into stories we tell each other in the dark, softly, like this. And when our own time ends, when our tiny spark goes out, the universe will go on exploding and cooling and rearranging itself. New stars will form from old ashes. New planets will circle those stars. Maybe somewhere new eyes will open. New minds will wonder. New hearts will beat with the same strange mix of fear and curiosity and love. In that sense, every explosion out there, every burst beyond supernovas is not just an ending. It's also a reminder that nothing here is still, that everything is in motion, that we too are part of that great, restless unfolding. So we sit here together, you and I, in this quiet moment, floating on a small rock around a modest star, wrapped in a thin layer of air, listening for distant thunder in a universe that is always, in one way or another, still learning how to burn. And somehow, in the middle of all that fire and darkness, we find the space to ask what it means to exist at all.